Hello again. Today I'd like to go over what happens to the thermal energy during a phase change. Okay, and let's consider water, which we're most familiar with, and let's pretend that we're going to add some thermal energy to an ice cube, taken straight out of a freezer. And that freezer, let's say, here's just an XY axis. We'll make this Y-axis our temperature in degrees Celsius, and we'll make our X-axis added thermal energy. And you know what units that would be in? That's right, joules. So I'll put a capital J for joules. And here's our origin. And let's say our ice cube is taken straight out of the freezer, and the freezer has a the freezer keeps the ice cubes at negative 15 degrees Celsius. Okay, we take that ice cube out. I'll just draw a little ice cube there. Ice cube. And now we're going to add heat to it. So we're just going to let it warm up. And we're going to try to we'll add that heat, thermal energy, to the ice cube at a continuous rate, at a steady rate. Okay? And so what's going to happen? We're going to see the temperature rise, and the amount of thermal energy that we added continues to increase. So we're going to end up seeing the graph go up and to the right, aren't we? Okay, but is it going to be a nice smooth curve? Well, it turns out it's not, because there are phase changes. You know, basically you're well familiar with the idea that ice cubes will melt into liquid water, and then if we continue to add more heat, that liquid water would eventually evaporate into a gas, water vapor. Okay, so let's follow those phase changes and see what happens. Okay, so now we start adding heat or thermal energy into the ice cube. Let's say we put it in some kind of a heater. Okay, that ice cube's temperature, if we have a thermal sensor in it, let's say it's a thermometer, this ice cube starting out at negative 15, the temperature starts to rise. And it continues to rise, and you notice we're allowing the heat to be absorbed at a steady rate, so therefore the graph is a nice straight segment at this point. What happens when it reaches 0 degrees Celsius? Well, you know what happens to ice, right? The ice melts into liquid water. So it goes from the solid phase to the liquid phase at 0 degrees. Surprisingly, the temperature during this phase change stays at 0 degrees Celsius for the entire amount of time when the solid ice cube melts gradually into liquid water. So it stays at 0 degrees Celsius. Now, once all of that ice cube has been converted to liquid water, then if we continue to add heat to this liquid water at a steady rate, the temperature is going to rise again. And it's not going to rise quite as fast as the ice did, but it'll keep rising, keep rising, keep rising until it reaches, guess what temperature? Until it reaches 100 degrees Celsius. Once it reaches 100 degrees Celsius, then that liquid water starts to be converted into water vapor or gas. So it's going from the liquid phase or liquid state to the gas or vapor state. So it's also known as water vapor. Okay, and during this time, transition where it's converting from liquid water to water vapor, the temperature remains at 100 degrees. We don't have an increase in temperature during that time. So that's pretty amazing. If we continue to add heat, even after all of that sample of that ice cube has melted and then turned to vapor, if we continue to add heat, that vapor, once it's all vapor, will then, once there's no more liquid, then the vapor will be able to raise in temperature again at a fairly fast rate, and that could go up into the hundreds of degrees. The thing that would stop it would be when the water molecule itself would tend to break down. Okay, so this could go up to 400 or 500 degrees or something like that. Okay, let's say we had 10 grams. Oops, I need to move this over a little bit. 10 grams of ice to begin with. That's going to convert to 10 grams of liquid water. That liquid water will then raise in temperature from 0 degrees to 100 degrees at this point, and then when it converts from liquid water, it'll convert to 10 grams of water vapor, and during that time there won't be a temperature change again. Once it's all vapor, then if more heat is added, more thermal energy is added, that vapor will then rise in temperature up to the hundreds of degrees. Okay, this is called a heating curve. Now if we go the other way, let's say we had 10 grams of water vapor and cooled it off, put it in the freezer or whatever, that water vapor would then convert to liquid water. The liquid water that would then cool down to 0 degrees. The liquid water would then give up more heat to the freezer, and it would convert to ice at 0 degrees, and then that 0 degree ice would, if we continued to remove heat from that, would be cooled down to, let's say, negative 15 degrees, or if it was even a more robust freezer, which could cool things down even lower, that ice could go down to negative 20, negative 30 degrees, negative 50 degrees, or whatever. Okay, now how many different steps do we have in this diagram here? We can call this a heating and cooling curve for water. Okay, so we call this heating or cooling curve for water. How many steps do we have? Well, we have one here, and that first step is where the ice is increasing in temperature from negative 15 degree ice to 0 degree ice. The second stage is where the ice itself at 0 degrees is melting into 0 degree liquid water. The third stage would be where the 0 degree liquid water is being converted to 100 degree liquid water, and then the fourth stage is where the 100 degree liquid water converts to 100 degree water vapor. The fifth stage then would be when the vapor, once it's entirely vapor, it can go from 100 degree vapor up to a very high temperature into the hundreds of degrees before the water molecule breaks down. Okay? Is that pretty clear? This is a very important diagram here. Okay, let's try a little problem. Let's say that we want to convert 10 grams of ice to 10 grams of water vapor. that happens to be at 200 degrees Celsius. So how much heat is needed to raise 10 grams of negative 15 degree ice to 200 degree vapor? That's our question. And you may guess that since this graph is in 5 parts, we may need to use more than one step. We may even, if we're going from negative 15 degree ice to 200 degree vapor, that would require doing 5 steps. Okay, so let's go ahead and get started. And it all comes down to, well, I'm going to stop at this point.